Okay, so in this session we will discuss the difference between a combinational logic circuit and a sequential logic circuit, right? So a combinational logic circuit and a sequential logic circuit, you see the difference between two is listed in this particular table. The combinational circuits, the present output depends on the present inputs, right? What actually this means is that the value which is available at the output terminals, right? So this particular value of the output is depending on the value of the current value of the inputs, right? In case of the sequential circuits, the present output, it depends on the present inputs as well as on the past outputs, right? So the outputs, if you can look at this particular block diagram of the SLC, so in this what we can observe is that the outputs, they depend on the inputs as well as the value of the previous / past outputs, right? So the output, whatever is the output, that is taken from this memory element, since this is provided as the feedback to this combinational logic circuit. So, and finally from this block if we are taking the output, and whatever is the output of this memory element, so combining this with the input will result in the output. So this is what actually we mean by this statement, that the present output, it depends on the present inputs as well as on the past outputs, previous / past outputs. Again, if you see, the second difference is there is no feedback in a combinational circuit. There is feedback present in a sequential circuit from the output to the input. There is no memory. In case of a sequential circuit, memory is present. So by the term memory, what we mean is that in this case, the output entirely depends on the input. There is no feedback mechanism, or the output does not depend on the previous value of the outputs. In case of a sequential circuit, the output depends on the previous values of the outputs, right, as well as on the present inputs. So that is why, since the sequential circuits have a tendency that they can store the values at their output terminal, so that is why we say that memory is present in case of a sequential circuit. Few of the examples of the combinational circuits can include multiplexers, decoders, half adder, full adder, right, encoder, decoder. All of these are examples of the combinational circuits. The examples of the sequential circuits include flip-flops, registers, counters, right? So all of these designs, they are the examples of the sequential circuits, right? This is the block diagram for a combinational logic circuit, right? If you can observe that the current inputs, right, if they are represented with the help of any number of input lines, then the output, if it is represented with the help of m output lines, right, then there is no feedback, and the outputs, they are directly depending on the value of the inputs, right? So this is a simple block diagram of a combinational logic circuit. In case of a sequential logic circuit, we'll be having a combinational block. The output of the combinational block is one of the output terminal of this block will be acting as the output terminal. The other output terminal of this block will be providing the input to the memory elements, right? If you see the memory element, by this term memory element, we should understand either this latch or flip-flop, because latch is the fundamental memory element, if you see, and the basic difference between a latch and flip-flop is just the presence of the clock pulse, right? So in case of latch, we usually say there is no clock pulse present. In case of flip-flop, we usually say the clock pulse is present, right? but the purpose of both is to store the bits, right? Since their purpose is to store the bits, so that is why we call them as memory elements. So the output of this combinational block, it is processed by these memory elements, right? And there is going to be a feedback mechanism present in these memory elements. So output of this memory element will be provided as input to this combinational logic circuit, and finally this, after final processing, will be taking the outputs. So the output, if you see, it depends on the input as well as on the, what we say, previous / past values of the outputs, right? So these are the few key differences between any of the combinational logic circuit and any of the sequential logic circuit, right? So briefly, if you want to summarize, so present output depends on the present inputs. Present output depends on the value of present inputs as well as previous / past values of the outputs. There is no feedback in case of combinational logic circuit. There is feedback in case of a sequential logic circuit. No memory is there, right? It means no feedback mechanism is there, or we can say the output only depends on the present states of the inputs. Sequential circuit, memory is present. It means that the output depends on the present state of the inputs as well as the previous values of the outputs as well. Few of the examples: mux, demux, half adder, full adder, right? Half subtractor, full subtractor. And for this sequential circuit, we can understand flip-flops, registers, counters as their examples. This is the block diagram of a CLC, that is combinational logic circuit. This is the block diagram of a SLC, that is sequential logic circuit. Now, this particular word that we say, the feedback, right? The word feedback. So we can clearly understand this by taking quickly a very simple example. That is, if we take the example of a half adder circuit, right? Half adder circuit. So for a half adder circuit, we can represent sum as A XOR B, where A and B are the two inputs, right? We can express the output carry, right? That is C, as A dot B. So if A and B are the two inputs for a half adder circuit, right? So if we represent the half adder with the help of this block diagram, so half adder is there. So two inputs are there, that is input A and input B. And we are having two outputs for this particular block, that is S and C. So if input A is there and if input B is there, so we'll be using one XOR gate. We'll be using one XOR gate to realize the sum. This is the sum. We'll be using one AND gate. We'll be using one AND gate to realize the carry, right? Now if you carefully observe, from the output to input, right? From the input to output. So if this is what, these are the inputs, these are the outputs. From the input to output, there is direct only, one way to proceed or to reach to the output. That is, there is no feedback mechanism. Similarly, if you want to realize the carry, there is one particular way by which we can reach from the input to output, right? So that is why we say there is no feedback present in case of combinational logic circuits. Now if you take a very simple example, right? The most simple example for this flip-flop, for this, what we say, sequential logic circuits, right? Sequential logic circuits. So the fundamental memory element is latch. memory element is latch, right? So if we look at it, so a simple SR latch, if we want to represent, so a simple SR latch with the help of two NAND gates, if we see, we can represent it like this. So these are two NAND gates. So this is one particular input, this is one particular input. We call this as R input, we call this as the S input. This is the output Q, this is the output Q bar, right? So if the output is connected to the, with the help of a feedback mechanism, if we say, if the output is connected with the help of a feedback mechanism like this, Q if it is connected to the input of S, and this if it is connected to the input of, right? So this is the fundamental latch, right? So such arrangement we call as the feedback mechanism which is present in this particular latch, right? So if S is 0, if S is going to be 0, the output is going to be, so if S is 0 you see, and if R is 1, the output will be, that is Q, it will be reset, it will be reset. If S is 1 and if R is 0, the output will be set. So this particular, what we say, configuration is termed as the S bar R bar latch. We also call this as the S bar R bar latch. S bar R bar latch. If S is 0 you see, and if R is 1, so if this is 0, then this is going to be 1. If you carefully observe, this is going to be 1, and if this is 1 1 1, output will be 0, right? So output will be reset. So such a arrangement that we obtain with the help of this feedback mechanism, we call this as the latch, since no clock pulse is present in this particular circuit, right? And what this feedback arrangement provides us the advantage is that it can retain the value at the output terminals, right? It can retain the value at the output terminals. So if you see, if S and R, if they both are equal to 0, right, then in that case that will be an invalid state. And if S and R, if both of these are equal to 1, right, so if S is equal to 0 and R is equal to 0, we call this as the don't care or the forbidden state, right? We call this as this state. And if S is equals to 1 and R is equals to 1, if you see this output Q, right? So this output Q will be retaining its value. In that case we call this as the memory state, right? So whatever be the value which is present at this output terminal, before S and R they both are equal to 1, so it will be retaining this same value, it will be retaining this same value, right? So that is why, since this circuit, which is the fundamental circuit of this sequential logic circuit, right, which is the fundamental memory circuit, and it is constructed using NAND gates, we call this as S bar R bar latch, since it has a capacity to retain the value, right, which is present previously at the output terminals, if both of the inputs, that is S and R, right, if both of the inputs are 1. So since it is showing such a capacity, so we call, that is why, for this reason we call that sequential circuits have the memory, right? And since the outputs, they are connected with the help of the inputs, so that is why we call that feedback mechanism is present in these circuits, right? So this is how we can understand these two fundamental points, that the combinational circuits, there is no feedback, right? So you see the outputs and the inputs only in unidirectional way you can assume you can consider a relation between these two, right? So only we can traverse only in one direction, that is from inputs to outputs, and outputs in no way are connected in a feedback mechanism to the inputs, right? So that is what this particular statement means, no feedback. In case of sequential logic circuits, feedback is present, right, from the output to the input. So this particular feedback presence, it actually results in the existence of the memory, you see. And since no feedback is there in the combination logic circuit, that is why we say no memory is present. This is the fundamental block diagram, and this is the the basic block diagram of a sequential logic circuit, right? So this is how we can easily identify and analyze the difference between a combination logic circuits and a sequential logic circuits, right? So that's what regarding the today's session for this topic that we call as difference between a combinational and a sequential logic circuits. Thank you.